Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about setting up a basic maneuvering scenario in Shipple3D using the Esso Osaka sample project files. So you'll need to make sure you have the sample project files downloaded from the Shipple3D website, which includes the Esso Osaka folder. We'll go through the process of setting it up and calculating the hydrodynamics so that we can look at the maneuvering project. The maneuvering response. So we're just going to open the Esso Osaka project file, and the first time you open it, remember that Shimmo3D stores all application data relative to a single project folder, and the sample project files don't have any data directly linked into them. So we just got to go through the process of going add existing data. I'll start off with panel hull. I'll select the project file here. You'll get these little messages saying directory data and panel hull file is being changed to the actual directory. And you'll need to go through and make sure you are selecting the patch hull input file in the actual folder you've saved it to for some of these data files. So go save and run. Panel hull successfully completed. So if you want to take a look and see what it looks like, we can go plot panel hull, and everything's looking pretty good there. We'll go to panel lid as the next step. Open the input file for that, and we'll need to change the wet panel hull input file name for the one we just evaluated. Save and run. It's already completed. If we go plot panel lid, you can see there's the lid just above the wet mesh. You can see panel outlines as well if you're curious to see what that looks like. Okay, next is rad diff. So we'll select this, and we'll need to make sure we go through and adjust the wet panel input file, the one we just calculated, as well as the lid file that we just generated. We'll leave everything else the same, and again, this will take some time to calculate, so just be aware of that through the natural course of evaluating the radiation parameters here. In the Fremo maneuvering case, we're not going to use any waves, so technically we can skip the diffraction calculations. So some time has passed. If we plot RADCO, we can now see the Esso Osaka radiation and diffraction, the radiation, added mass, and damping properties, generally which look pretty good, nice and smooth, no spikes in the response. The condition numbers are generally pretty low, but still they're not looking like they're affecting, there's nothing affecting the response that much. So now we'll go to the next application, build ship, and open the build ship input file. We'll have to change the radiation diffraction database input file name, the dry panel hull. We'll leave all the other properties the same. Note that there's a rudder and a propeller already added, of course, as well. So we'll go run and plot ship if you want. Now you can see, I like to show the panel outlines myself. You can see there's the propeller in blue and the rudder that's been added there as well. So next up, we can actually run through the maneuvering case. If we go to Fremo, and we've got a forward speed turning maneuver. That's part of the validation cases of Shipmo3D using the publicly available Esso Osaka dataset. So we'll open this result here and use our ship model, assembled ship motion database that we created in BuildShip. So note there's already a bunch of parameters set here. The maneuver inputs are specifying at the very beginning The rudder is set to maximum deflection at 35 degrees, and then we're just simply running a 2,000 second simulation, along with there's an initial forward speed of 10 knots. Note the hull force option is set to linear. There is buoyancy for outcry law, but usually that's used for more extreme sea states and so on. So just go save and run, and the time domain simulation is done. So we'll just go plot trajectory, and then you can get a sense of how the system's going through its turning circle there. So just wanted to give an overview of what that looks like, what a maneuvering case looks like, but also how to get up and running with another set of sample project files with the Esso Osaka. Thanks for watching.